Hello everyone. In this video I will be explaining about how to find limit graphically. Let's make an introduction first. Limit is a value that function is heading towards when x value is getting closer and closer to a fixed number. So it's not about what's going on at that fixed number. It's about what's going on around that fixed number. So we will be focusing on the behavior of the function at a target point. In order to have an idea about the behavior of a function at a fixed number, we should check the right side of that number and left side of that number. So we are going to be looking at the behavior of the function at the right side of that point and left side of that point on the graph. Let me show you the notation of limit first. So we will write limit as lim, and underneath we have x with arrow follows, and after the arrow we are going to write the number, the target point the x is approaching, and f of x, and we read this as limit as x approaches to c of f of x. So as I said earlier, in order to have a limit, we should check right and left side of that number that x is approaching. So we should have the same number from right and from the left side. It means limit as x approaches to c of f of x is equal to, let's check the right side of the limit. We write the right side of the limit as limit as x approaches to c from the right. We write from the right by using superscript plus as a superscript for c of f of x, which must be equal to the left side limit, which also means limit as x approaches to c of c from the left. We write negative as a superscript to indicate that x is approaching from the left side of c of f of x. So we have a limit, we have a value that function is approaching when limit x from the right is equal to limit x from the left. So let's take a look at some examples to make sense. For example, if we are asked to find the limit as x approaches to 2 of f of x, all we have to do is checking right and left side of the function at that point. So it means we look at 2, the number that x is approaching from the right, when the x values are getting closer and closer to from the right. What is our function is doing? Look at the function at that point. At that point, the function is heading towards number 4. It's a value, it's a y value. So we are looking at the y value. Similarly, as x approaches to 2 from the left, the function is also heading towards 4. So from right and from left, the function is tending to 4. So we say limit as x approaches to 2 of f of x is equal to 4, because this is the value from the right and from the left. There is no break, no jump or stuff. It is pretty much similar to evaluating functions. When you look at number 2 on the x-axis, go up, and the corresponding y value for the graph is 4. So, as I said earlier, it's not about what's going on at that point, it's about what's going on around that point. So, it doesn't have to have a field point at that point. So, the target point shouldn't have to have um, a field point. It can be an empty point as well. For example, in this graph, we have an empty point here at 1, but the question is not asking about the value of function at 1. If it were asking about the value of function at 1, we would say undefined because it's not defined, it's empty. But it's about limits, it's about the behavior of the function around that point. What is the function doing when x approaches to 1 from the right and from the left? When it is approaching from the right, the function is heading towards that point. When x is approaching from the left, the function is also heading towards the same point. So from the right and from the left, we are approaching the same point whose y value is 3. So we say limit as x approaches to 1 of f of x is equal to 3 here. Alright? Another example. Let's take a look at the limit as x approaches to pi over 2. Here is pi over 2. When you go to your graph, when you go up, for example, we don't hit any graph. It's going definitely, indefinitely. When I go down, I don't hit any graph. It also doesn't hit any graph. It goes indefinitely. So there is no graph. There is no corresponding point, filled or empty. So we don't have a limit here. This one is heading up to positive infinity. This part of the graph is heading down to negative infinity. They are going far away from each other. They are not connected. They are not about to touch each other. So at this point, as x approaches to pi over 2 from the right, this part is heading down. As x approaches to pi over 2 from left, this part is heading up. So we can't talk about any limit here. So limit does not exist. They are not heading towards the same point. They are going in different directions, opposite directions actually. So no limit. Limit does not exist. Another question, we will be focusing on a lot of different examples here. So what is limit as x approaches to 3 of h of x? At 3, go to your graph. Here I have a graph. I have a filled point and empty point, but I don't care about the point. What I care about is the graph, the behavior of the graph. As x approaches 3 from the right, my graph is tending to this point. As I approach 3 from the left, my graph is tending to the same point. So they're about to touch the same point. So the y value that they're about to touch, that they're tending to, is equal to 3. So the value of limit here is 3. Another question, what is h of 3? This time it's asking about the value of the function at that point. It's not asking about the behavior of the function, it's asking about the value of the function at that point. So which means we will be searching for a field point. Alright, so what is the field point at 3? At 3, when I go up, there is an empty point. I can't use an empty point. It's undefined. Function is undefined at empty points. We should go up a little bit more to hit the field point whose y value is equal to 4. So h of 3 is equal to 4. Alright, so to evaluate the functions, all we care about is a field point. To evaluate a limit, we don't care whether the point is filled or not. We just focus on the behavior of the function near that point. Let's move on. Still the same question, same graph. What is limit as x approaches to 4? So let's take a look at point 4. At 4, here I am. Let me use another color, not to confuse. Okay, at 4, when I go down, there is no graph. When I go up, there are two parts of the graph. I don't have just one part. I have two parts. So I have a broken graph here at 4. There is a jump. When I head towards 4 from the right, my graph is tending to this point. But when I approach 4 from the left, my graph, the other part of the graph is tending to this point. So as you can see, there are two different points that my function is approaching. So as we mentioned before, in order for us to have a limit, the function from the right and from the left should approach the same point, not two different points. So we basically can say limit does not exist because from the right it's 1, from the left it's 4, two different numbers. So we can talk about the limit here. Limit does not exist. So we say does not exist. What about the next one? Still the same graph. Limit as x approaches to 4 from the right. That plus indicates that um, x is approaching from the right. So from the right, let's go back to the graph again. From the right. So even though we can talk about the limit at a point when there is a jump, we can talk about a one-sided limit. All right. So even though we say limit as x approaches to 4 of f of x does not exist, we can talk about the limit as x approaches to 4 from right. There will be a value, and we can also talk about the limit as x approaches to 4 from the left of f of x. There will be a value. So just because we don't have a limit at a fixed point doesn't mean that we don't have a limit on the right, from the right and from the left. We have limits, but one-sided limits. So it was asking about limit from the right. From the right, as I'm approaching 4 from the right, my function is heading towards to that point whose y value is 1. So from the right, it's 1. From the left, it was 4. Let's answer the question. The answer to this question is 1. So it's B. So we will look at the right side of the target point. My target point is 4. This part of the graph is from the right. This part of the graph is from the left. So we focus on right side graph, whose corresponding point is 1. All right, let's move on. Another question. What is limit as x approaches to 3? Let's find 3. Check both sided limits. Limit from the right side. As I approach 3 from the right, my function is approaching to this point. Similarly, when I approach 3 from the left, my function is approaching to the same point. Remember, I don't care about um, individual points, I care about the graph. So let's take a look at the graph. The behavior of the graph is important when we talk about limits. From the right, it's this point. From the left, it's also this point. So they share the same point. Since limit from right and left are the same, then the value of the limit at this point is this point, whose value is 1. All right. The next one is not asking about limit, it's asking about the value of the function at 1. At 1. If we were talking about the limit, we would say does not exist because graph is broken. There is a jump. From right, we have a part. From left, we have another part. So they have two different values. But the question is not asking about the limit. It's asking about the value of the function at 1. So what are we looking at when we are asked to find the value of the function at a fixed point? We are looking at a field point. So let's take a look at the field point. So which point is field? This or this? So that one. When we go down, we see a field point. So we say g of 1, the value of the function at 1, is equal to -1. All right. Let's move on. Still the same question, the same graph. What is limit as x is approaching to positive infinity? So this is what happens when x approaches to 3. It is 1. What is going on at 4? It is also 1. What's going on at 5? It's also 1. At 6, 1, 7, 1, 8, 1, 10, 1, 9, 1. So it goes to infinity. When x values are heading towards the infinity, the y value does not change because this part after 3 is a constant function. It is a line. It is always the same, right? No matter what the x value after that point is, it's always 1 because it's a constant function. At 10, 100, 1000, as x approaches to positive infinity, as x as x heads towards the positive infinity, y value doesn't change. It's always that value 1 because it's constant. Okay, don't confuse when you see the infinity. It doesn't change because it's a constant function. One last question about the same graph. Limit as x approaches to 1 from the left. 1 from the left. All right. So I have 1. We will be focusing on left side of 1. So this is right side. This is left side. So let's focus on the left side. As x approach 1 from the left, the function is heading towards that point. What is the value of that point? The value of that point is negative 1. Okay, my answer is A. Let's move on with another question. The idea is always the same. The more you practice, the better you'll get this subject. It's actually pretty much easy. At first, it will be confusing, but later on, as you do more practice, you'll get used to it and you'll find it easy actually. Okay, one-sided limit. Limit as x approaches to pi from the left. At pi, the function is broken. There's a jump. I have a right part and left part. What am I looking at? I'm looking at the left-sided limit. Left side. So the left part is left-sided limit. The right part will give us the right part, right-sided limit. I am asked to find pi from the left. As x approach pi from the left, then the function is heading towards to this point. So don't look at that part. Look at just the left part. Let's consider there is a wall here. You don't see this part, right? You just see the other part, the left part. So what is the point at pi when you go up? It is this, whose y value is 2. All right. What is the value of the function at pi? It's not limits, it's evaluating functions. So we are looking for a field point. Which one is field? Let me clear this a bit. Which one is field? So I see a field point here. The field point is not this. Apparently, it is this. So what's the value at that point? It is 2. The value of the function at pi is equal to 2. Now one last one about this graph. Limit as x approaches to 0. When I look at 0 from right, this is the graph. This is the point where my graph is heading towards. 0 from the left. This is also the point for my graph. So the graph is not broken. There's no jump. So there's just a value. There's just one point that the function is tending to from both sides. There's just one point. The graph is connected. There is nothing worrying here. So it is just 0. Alright, from the right, from the left, they're both approaching to 0. All right, let's take a look at a ministry exam question. Which one is true for the given function f? Let's check the options one by one. We are gonna go with the options. They're all asking about the same values in the options. See, no, not the same. Limits as x approaches to 1 of f of x is 4. Is it true? Let's see. At 1, what is the limit? Is there any limit? See, at 1, there's a jump. The left side is different than the right side. The left side is heading towards 3, while the right side is heading towards 4. Two different y values at 1, so there is no limit. Limit does not exist at 1, so I don't need to check the others. Do not waste time by checking the others. If one of them is wrong, it's wrong. Option B, 4 from the left. Let's go 4 from the left. There is only one graph, one part. It doesn't have a right part. It ends here. So the point at 4 is 3. The corresponding y value at 4 is 3. So it is the value of the limit, left-sided limit. What about the limit from the right for 1? At 1, there are two parts. You look at the right part. At 1, this is the left part, this is the right part. So at the right, the value of the function at 4, the function that's heading towards 4, it's true. What about the value of the function at 1? At 1, when I go up, I should look at the field point. Which one is field? Apparently not this. This is field, whose value is supposed to be 4, not 3. So it's wrong. So this option is also wrong. Option C, 3 from the right. At 3, there is only one point. They're both from right and left approaching the same number, whose y value is 3. True. 1 from the left. 1 from the left. This is right part, this is left part of 1. When you consider there is a wall here, this is the left part, whose y value is equal to 3, not 1. So this is also false. So I don't even have to check D. It is D, since the others are wrong. Let's move on and finish this lesson by solving one last question. Which of the following graphs satisfies these conditions? F of 2 is undefined. Let's check each option one by one. F of 2 is not undefined. There is a field point here. So this option is false. F of 2, there is no field point. It's undefined. True. The first condition is satisfied by option B. 2 is undefined in C. At 2, it's undefined at B. So I just eliminated one option with this information. Another information, limit as x approaches to negative 2 from the left is equal to 0. Negative 2 from the left, I don't check A, I check B, C, and D. Negative 2 from the negative direction. So when I approach negative 2 from the left, my function is heading towards this point, right? This is the left part, this is the right part. Left, right. When you think there is something here, this is right side of this graph at negative 2, this is left side. So at the left, the function is tending to this point whose y value is 0. That's true for this graph. For that one, negative 2 from the left, it's heading towards this point, still 0. Negative 2 from the left, heading towards 0. This is also true for this graph. So this information is satisfied by these three options. Let's move on, use the other information. Limits as x approaches to 2 from the right. 2 from the right is 3. 2 from the right. Which part is right? This part is right. So what is the corresponding point at this part? This one, whose y value is 2, not 3. It is 2, so this is wrong. This option is wrong for this information. What about that one? 2 from the right. At 2, I have two parts. This part is left side of 2. That part is right side of 2. So let's take a look at that part, whose y value is, at this point, 3. So this is true for this information. Last option, 2 from the right. At 2, this is left part. This part is the right part of 2. So at the right, I will use that part of the graph whose y value is 1, not 3. So this option is false. My correct answer is C. I checked the third information too, so I didn't have to check the last information. By using three information, I answered the question. The correct answer is C. So multiple choice questions are solved in this way, trying and error. We just try options one by one. So that's all for this lesson.